Okay, ladies and gentlemen, could you take your seat? Okay. Okay, so welcome again. Now we are in the last technical session for today. I think you have working hard for the whole day. My name is Thiravat Bunyati. I am the Vice Chairman of Thai Geotechnical Society and will be your moderator for this keynote session. Now, it's an honor and prestigious to be here to introduce the keynote speaker, Mr. Junichi Yamasaki. He graduated from Tokyo City University in Tokyo, Japan, long time ago. After graduate, he has been working in the field of ground improvement for more than 40 years, particularly the application of ground improvement for the metro and high-speed railway in Japan. Now, he became the president of Sanshin Corporation since 2018 and also serving as the president of Japan Anchor Association from 2021. He also interested in the field of development of ground improvement technology and also the application of grouting as a mitigation for liquefaction. So now, without further ado, I would like to ask Mr. Yamasaki to deliver your keynote to our audience, please.
First, please have a little patience with my poor English. I'm grateful for the opportunity to present today at this large conference. I belong to a Japanese construction company specialized in ground improvement technology. And our company has been pursuing jet grouting for over 50 years. We hope that our company's experience and knowledge can be helpful for the future development of Southeast Asia. I would be happier if my talk sparked your interest in jet grouting. The content of the presentation is as follows. The jet grouting is a ground improvement method that created improved ground by eroding and mixing the soil using a high-pressure injection of cement-based hardening materials. The video shows a state of jet water in the air using actual mechanical equipment. Hardening material is jetted horizontally from a jet device attached to the tip of the boring rod, and the rod is rotated and pulled up to create a cylindrical improved body in the ground. The excellent feature of jet grout includes a wide range of applicable ground, high strength of the improved body, the possibility of construction by drilling small diameter holes, and the possibility of construction in narrow construction space. Let's look back at the history of jet grouting. This technology began in Japan in the late 1960s, when research was conducted on the jet for rock cutting as a ground improvement tools. In the early 1970s, a Japanese company's proposal attracted attention at the time of the international competition for stabilization of the Leaning Tower of Pisa, and the spread of the technology to Europe began. In the 1980s, it spread to Italy, Germany, the United Kingdom, and other European countries, and then expanded to the United States, Canada, and South America. Since then, many construction methods have been developed in the progress stage up to the present, and construction technology has evolved significantly and along with the evolution of machinery. The provided images photo shows construction situation in Japan past. The left photos date back to the 1970s and can be considered the precursor to the current construction techniques, with the lower photo representing the prototype of present-day construction method. The upper right photo shows construction from the 1980s, while the lower right photo shows the construction scenario from the 2000s. Today, various jet grading methods have been put into practical use, but the most important factors for each jet grading technology are the type and the number of fluids used. In the historical evolution, these three different jetting methods are available technology: single fluid, double fluid, triple fluid system. A schematic diagram of the improvement mechanism is shown. If the injected jet stream collides with the original ground at sufficient speed, it can cut the ground. The improved body is created by mixed and strings the space filled with mixed fluid composed of groundwater. Cut soil particles and jet fluid. The jet mixture eventually replaces the soil particles, and the excess is expelled around the rod to the surface. We have been conducting investigation into the characteristics of energy decay in jet stream through underwater jetting tests and full-scale ground injection experiments. The results have provided insight into fundamental performance aspects, such as the relationship between jetting specifications and the diameter of the improved column. Figure A illustrates the experimental setup underwater jetting test. And we can form the attenuation situation by distance. Figure B shows the result of 12 test cases using the same monitor, but varying the jetting pressure, node diameter, and air injection rate. A similar attenuation tendency is observed in the collision load, and the relationship between the injection pressure, node nozzle diameter, air injection amount, and the reach distance at which the predetermined collision load of 3 patterns can be obtained to shown in Fig C. Equation 1 is correlation formula when the collision load is 100 kN. In a full-scale ground injection experiment, we conducted construction using various jetting specifications and subsequently excavated the improved columns in verify their find forms and qualities. Previous research reports and our independent studies have led us to believe that the ground cutting distance is correlated with 5 factors related to the jet stream. And we are creating the improved structure by changing each factor. By altering these factors, we performed the creation of the improved column. Based on this result and the consideration of the jet test in water, the relationship between the injection parameter and the diameter of the improved body was examined. This is the result of ground injection experiments on a full-scale test. A relational expression, equation 2, was derived for the correlation between the moving speed and eroding times and the ground cutting distance. Fig D shows the relationship between the eroding times and the ground cutting distance. And we can see that the ground cutting distance increases by 10% when the number of cutting increases from 2 to 3 times. By examining the above two experimental results, the relational expression, equation 3, between the injection specification and the ground cutting distance was derived. Figure F shows the correlation between the derived equation and the results from the full-scale ground injection experiment. The relationship equation presented here is specific to our construction system and its jetting specifications. However, we believe that it demonstrates the fundamental principle of jetting characteristics and marks a significant step in understanding these processes. The jet grouting methods have evolved over several decades, progressively enhancing its value through various stages of development. During the evolution process, efforts have been made to increase the added value of the technique. The figure below presents an overview of the challenges considered during the development of new jet grouting method, along with the achievements resulting from solving these challenges. In the figure, for example, achieving high-speed excitation can lead to shortening of construction period, which in turn enable benefits such as reduction of cement and reduction of industrial waste. As a result, this can lead to the realization of reduction of construction cost and reduction of environmental load. VJET method was developed with the goal of large diameter and high-speed execution. By establishing a construction system and specifications, including a proprietary monitor, and method was successfully put into practical use in 2011. The realization of the development goal is based on the evolution of the ultra-high pressure pump, which is the core of construction equipment, and the monitor that suppresses energy loss during injection and enable efficient ground cutting, mixing, and string in a short time. This is possible due to the construction specification established by analyzing experimental data and a lot of accumulated experience. The construction system of the VJET method is classified as double fluid system that injects hardening material slurry and compressed air at high pressure. The method offers 4 types of construction specification based on improved diameter categories, each utilizing a combination of machinery and equipment. This enables the design and construction within the range of effective diameters from 1.5 meter to 6.0 meter. Here are some photos depicting the construction progress. The photo in the bottom left shows a tablet device that allows real-time display of construction data such as depth and injection condition. This tablet is used to monitor the construction progress. We have expanded our construction result even under more challenging conditions. The photo on the left depicts a station where construction is being carried out on a subway station expansion project during no operational hours. Small machine is used on the track after the station has closed for the day. The construction achievements of the VJET method continue to increase steadily, with a total 400 projects and an overall improved volume of 935,000 cubic meters in Japan as of the end of March 2023. Other related technology, the JWM system has been developed and to monitor the jetting condition of the improved body in real time. This system measured and quantified change in the acoustic characteristics of jet stream that's like measuring pipe installed within the improved area in the ground. By analyzing the obtained data, we can allow for estimation of the improved diameter at each depth. As shown in the figure, multiple measurement tubes are arranged at different distance from the center position of the improved body, and the arrival status of the jet at each measurement tube position is measured. The measurement results are represented in the form of time axis graphs depicting a consistent interval, as illustrated in the diagram on the right. The magnitude of cutting energy is observable as the height of these graphs peaks. The height of these peaks is evaluated as an indicator of the strength of the jet stream. Using analysis software, the improved diameter at each device is estimated. This technique is primarily employed during trial test or in the initial stage of construction, and has been used to confirm the construction status of improved body in more than 50 construction projects. In 2012, we started the construction work in Hong Kong. And since then, we have accumulated construction results in Taiwan, Malaysia, Singapore, and Thailand. In recent years, within the Southeast Asia region, the rapid jet method, a construction method that applies the knowledge and technology of the V-jet method and have improved handling properties, has been developed. This method has been employed in various applications, including ground improvement for excavation base, underground preceding beams, and protection construction for launching and arriving of TBM, particularly notable in the Bangkok subway project. In 2015, a licensing agreement was established with the construction company in Australia. This partnership led to a series of construction accomplishments in European countries, with a focus on Germany and Austria. JetGrout has great potential as a ground improvement method, and we are confident that it will continue to be widely used around the world. For JetGrout to continue to develop, the participation of many researchers is necessary. In addition, many construction engineers must be involved in expanding the technology. I would like to cooperate with many engineers around the world and contribute to the further development of technology. Thank you for your attention.
Thank you very much. I think we still have time for a few questions. So if you have questions, you can. Okay, please.
Thank you for your presentation. From your presentation, I saw the instruction about the cutting capacity of the jet stream. So they use the injection pressure, injection volume, cutting time, and cutting frequency. And how about in the parameter is the actual condition? How do you, what are them? Yes, thank you.
Thank you. I help he.
I translate your very good English to Japanese. It's okay. So we
So
will
please speak on the microphone. Please.
質問です。
そうですね。で、質問されたのが
どうやって決めるのか。
どうやって決めるね。切削能力と切削能力と噴射圧力、突出量、エアなどのコントロール。どうやって決めるの？
ここら辺。
喋ればいいんですよね。
喋って。
日本語喋って私英語しますか？
日本語でちょっと喋るんで、それを通訳してもらいます。
So he will answer in Japanese first, and his colleague will translate it to English.
実用化の段階では、まず噴射圧力、それと突出量、エアの噴射量について、使用する、設備によって設定できる範囲が決まります。
When we developed this jet grouting method, we have a lot of the parameter in our hand. In that time, we have know how to do the jet grouting, and we know the range of all the parameter.
それと期待する改良体の大きさによって改良に必要なセメントの量が計算できます。
Then, based on the parameter, then we can calculate how much the cement we use, how much the sludge out will coming out. Then we can know. Then we calculate this one in advance.
でこれらのそれぞれの条件を満足する噴射仕様を検討して、それに合った圧力、突出量、エアの噴射量、それとロッドの引き上げ時間、あと回転数を、それともう一つスラリーの配合、それを設定します。
Based on this parameter, then we will propose the good final parameter about the pressure, so upping the speed and the air volume and rotation speed and the cement proportion or the sludge coming out, the versatility, all of this one. Then we design the parameter.
で実際にV ジェットで、どのように設定しているかというと、噴射圧力が35メガパスカル、降下台の突出量が360リッター毎分、エアの噴射量が、10リューベ毎分、それと引き上げ速度が1メートルあたり9分、あと回転速度は5から9 RPM。
Then we take an example. If we use the V2, then the jetting pressure 35 MPa and the jetting flow is 360 liter per minute. Then the air jetting volume is 10 cube per minute. Then the setup speed is 1 meter. We set up 9 minutes. And the rotation speed, we set up from 5 to 9 per minute. About this one. This is our standard parameter in V2. Okay?
Okay.
Thank you.
I answer your question?
Yes, thank you.
Thank you.
We still have time for one more question, if you like.
I would like to ask for the GWM system. How does it utilize in construction? Yeah, I would like to know how does it utilize in construction. for GWM system.
Sorry?
I saw that GWM system and the slide.
JWM system?
Yeah. How does it utilize in the construction model?
So you mean how to
Yeah.
check the diameter
Yeah,
of
something
the
like that.
check ground column?
Yeah,
Okay.
something like that. Thank you.
さっき説明したように、中心からいろんな距離に複数の、ターゲットを設定します。
Then we set up surrounding the check routing pier. We set up 3 to 4 testing pipe.
ターゲットパイプ。それでどのパイプに、届いたかっていうのを、実験によって判断します。
Then when we started jetting, the check routing will hit the testing pipe. Then we check the pipe is be reaching or no by the sound. So you can see the sounding curve over there. Then we use the sounding curve to really to check out the jetting pipe is to reach our planning size or no.
で設計を満足する結果だったら設計通りに施工しますし、もし、十分な大きさの、改良体ができないと判断したときは、引き上げの速度を、遅くしたりするようなアレンジをします。
Then if it is in our expectation to get the diameter, then no problem. We use the parameter. Then if the diameter is smaller, then maybe we will choose the other parameter like
more slow.
step up speed or rotation more slower, something to adjust our parameter to reach our target diameter. Can I answer your question?
Yeah. Thank you.
Thank you very much.
Okay, so last question.
発表ありがとうございました。
おお、すごいですね。
私は佐賀大学の理工学部地盤工学の新出て町路調整と申します。この発表すごく興味を持ってて地盤改良に関する研究をやってます。今博士3年目です。この技術って他の国、例えばアフリカとかを拡大する予定とかありますか？
Okay, maybe I need to translate to English. He come from, I think, Africa, right?
Yes.
Then now he study in Japan.
Yes.
大学どこですか？
佐賀大学です。
佐賀大学？
はい。
And he studied in the Saga University. Now he's a doctor course, right?
Yes.
博士 course, doctor course. Then he think it is a very interesting check routing method. Then it is possible to extend to Africa.
もちろん前向きには考えています。
And we were looking up to expand this WeJet or RJet system to Africa.
ただ特別な機械を使いますし、あとは、ある程度の経験が必要になりますので、その辺は技術指導をしっかりやらないといけないと思ってますので、単に機械を売ってできるというふうには考えていません。
Then this method need a special machine and a special tool. Of course, not everyone can do, not every laborer can do. So need to do a special care to teach the local team. So if everything is possible, then we can go.
Thank you very much. ありがとうございました。
Thank you very much.
Okay, so I think we're running out of time now. I forget to tell, especially for student participants, that Mr. Yamasaki also wrote several papers. So you may find your free time to go Google Yamasaki J and read for his experience from the papers. Okay, at the end, on behalf of the organizer, I would like to give a gift as our token of appreciation to your presence. Okay. So there will be announcements. After this, for those who will join the dinner will be held on this room. It will start 6:30. And for tomorrow, I am afraid to inform you that one of our keynote speaker, Dr. Shin, has some inconvenient to join us. So for tomorrow morning keynote session, it will be cancelled, but we still hold the exhibition. So you may use that time to see several interesting things and also use it as a business opportunity to talk and exchange the information with each other. Okay, thank you very much. Because we need to arrange this room, so I'd like to ask everybody to go out of this room so the staff can rearrange the table for the dinner. Thank you.